Hey there everybody, and welcome to the POT video course. As you already know, in this course I'm going to show you how to take footage of a pigeon that is going to be provided. You don't need to film your own footage. We're going to take it and make it smoke a blunt, which seems stupid until you realize all that's involved with that. We need to do some 3D tracking. We somehow need to extract the position of the beak, which is weird because we can do a 2D track, but we need to know where it is in 3D space and all this. Of course, we need to model a joint. We need to do some fire and smoke simulation, make it realistic, render it all together. So there's actually quite a bit that goes into this pigeon toking. So thank you so much for purchasing the course, and I hope you're going to learn a lot for $4.20. I hope that you get a lot of value out of this. And let's begin. Okay, welcome to part 1, where we are going to be talking about 3D tracking, but first let me explain why we even need to do a 3D track. So the goal, again, is to take this footage of a pigeon and put a blunt in its beak. Now, you might think, oh, just track the 2D position of this and then stick a joint onto it. No, because we need to have this thing rotate in 3D space, we need to know its 3D position, and there's no way to extract where the beak is just using a 2D track. We somehow need 3D information of where it is in 3D space, which is hard because we don't have that info. So the game plan is we're going to do a 3D camera solve. So it's going to be, how is the camera moving? So basically we're going to track the ground. And then the trick we're going to use, because we still don't know how tall the pigeon is, like where the beak's going to be, we know where the feet are contacting the ground, so we already tracked the ground, and then using that we're going to extrapolate some height information and do a bit of a projection to get the 3D position of the beak. Of course, that doesn't make sense yet since we haven't done it, but let's get into it. So first thing we need to do is a 3D solve of the footage. So footage is provided, go to the movie clip editor and import it in. So I'm going to go to the pot folder, import in the pigeon base, and here's our footage. Now I'm going to assume you've done a bit of tracking before, but I'll kind of lay down all the groundwork. Before we begin tracking, couple things. Hit set scene frames. This is going to make sure that the frame number of our project doesn't go beyond our footage, so it's 126 frames. Hit prefetch to load it into memory. In the output tab, so this is just the checklist, take your frame rate and match it. So this, I guess it's 29.97, not too important if you do that, or 30. Match your frame rates, and then in the render tab, go to color management and set this to standard, just so we can see our footage as it was shot. So to get a 3D track, I've explained this a bunch of times, but what we need to do is add a bunch of trackers. So I'm control clicking. We need to take all these 2D trackers and have at least 8 of them throughout the shot. And once we do that, and those 8 can swap in and out, but once we have 8 trackers at any given time, we can solve where the camera was moving and all this. So for these trackers that I'm adding with control click, I want them to have certain properties. I want them to be normalized. So everything we do here is going to import with these trackers. I want them to be normalized. This means that the tracker doesn't care if a shadow gets cast over it. It's invariant to lighting. I want the motion model, the match to be previous frame. So instead of picking a frame like frame number 1, adding a tracker, and then every frame in the future it's comparing to that, previous frame just says look at the previous frame and then move it. Look at it, move it, and it's a bit more finicky, but it's much more of a sticky track, if you will. Finally, with our track, we have the pattern size, the thing that it's tracking, and then if you hit Alt-S, you can see the search size. I want the search size to be bigger since this is a fast-moving shot, and let's make the pattern size bigger too. So now whenever we add a tracker, it's going to have all these properties. So for example, let's put a tracker right here. This seems like a well-defined point, so S to scale, and I want to track this. You can either go to the track panel and go like frame by frame by frame. So you could go like this. This actually tracks it fully forward. Or you can literally do the frame by frame button and like make sure that it's tracking correctly. A shortcut for this is Alt right arrow, Alt left arrow to track forwards and backwards. And you're going to see, as is the case with many of these trackers, we're going to go out of frame. So once it's out of frame, hit Control L to lock the tracker. And we basically need to keep doing this process, and it's not that lengthy. You just kind of keep adding trackers until we have 8 at any given point in the shot. So maybe I could go to frame number 6 where this feature is visible, track backwards, alt left arrow, and then track forwards. And by the way, cool trick, if you hit L, it's going to lock the tracker so we're kind of stabilized on that view. And you want to make sure you don't go too far because you can see this is going to keep tracking even though the feature is lost. So you can trim the rest of the track. A good way to visualize this, by the way, and again, this isn't meant to be an intro to tracking, just kind of a reminder. I have a lot of tutorials on YouTube about tracking. I just want to talk particularly about this shot. A cool trick is if you open up another movie clip editor and go to graph, we can actually see the XY data of these. And this will tell us where we do and don't have trackers. So at this part of the shot, the second half, we don't have any trackers, obviously. Okay, so I'm going to add a tracker. Whoops. That is not what I intended to do. I want to open this thing back, but there's no room to open the window. Okay, we'll do something like this. Technical difficulties. What are you going to do? Full screen. Okay, disregard that. We add a tracker. We track forwards. Once it's gone, Control L to lock it, rinse and repeat. Now, normally, I wouldn't show all of this because it's going to be kind of stale. But I figure even if I'm like silent during it, it's helpful to see how I track. So I'm just picking features that are high contrast. So if I can track it with my eye, then the computer can definitely track it. So I'm going to add a tracker here, alt right arrow, see how long it lasts. Ideally, we're going for long-lasting trackers. And again, we're looking for 8 at any point in the shot. I'm picking some that are far away, some that are close, just so we have a lot of 3D information about parallax and all this. So I'm just picking spots, alt right arrow. And yes, there is kind of an automated way to do this with different programs, but I wanted this to be kind of Blender native, and I'm sure you appreciate that. Okay, here's an interesting scenario. You see the pigeon's about to cross. You can see it's going to keep tracking, so you have to moderate it. The track might keep going because of this previous frame where it's not supposed to. And again, you can clear, and you can see this information is starting to get messy over here, right? You can clear everything to the right of the given frame. Let's track backwards. I'm going to go to the last frame where we have nothing. I'm going to say, let's track a feature like this. Alt left arrow to track backwards. Again, it might go too far, so clear everything to the left. Okay. And it's good to work forwards and backwards. That way you kind of fill in the data coming from both ends. So I'm just picking areas that I think are going to last a while and the pigeon's not going to intersect. So that was a good tracker. That lived for a long time. And again, longer living trackers are ideal. Oh, this one starts getting glitchy when the pigeon starts coming over it. Okay. Let's do a spot like this one. And by the way, at some point it might just stop tracking. If this is the case, you can just add another keyframe, or you could do it manually. So you go to the next frame, you say, oh, it was like roughly here. But if you're not sure about it, you don't have to do that. So we could just kill the tracker. Okay, let's add another tracker here. Track forwards and then track backwards. So this was like in the middle. And you can see we're filling in the data from both sides. Okay, so now I'm going to do this kind of speedy. And forgive me if I'm not talking as much. But again, I want you to notice which areas I'm choosing to track. Am I tracking forwards, backwards? Do I need to clean up the track for any reason? Stuff like this. So now I'm going to the middle. We have only 2 to 3 trackers alive at this section. This seems like an obvious spot. Track forwards or backwards, track forwards. Beautiful. And again, just to emphasize, since it might be unclear, you don't need to have the same 8 trackers throughout the whole shot, and 8 is the magic number that Blender needs to calculate a solve. But those 8 can switch, right? So some come in and out of existence, of course. But the nice thing about this shot is that the ground has a lot of detail for the trackers to latch onto. That's for sure. Okay, so we're actually almost done. Doesn't look like it, but we are. Because it seems like we have roughly like 5 to 6 trackers at any given point, which means we're very close. Just trying to come up with a narration that seems original as I'm doing the same repetitive task. I'm sure you can tell. Okay, at the beginning we do have 8 trackers. Beautiful. Then some blip away, so we need to add a tracker at roughly this time period. Track forwards. Okay, now we, again, don't have enough trackers, so I'm just going to pick a feature right here. Beautiful. At this point, I believe we have 8 trackers. We keep going. I think here we have too few, so add another detail. Like that. And let's do a feature up here since we don't have that yet. So sometimes it's just going to stop tracking since it can't follow the pattern. We could try increasing the search area. No, it doesn't seem to like that. Okay, we can lock that tracker in a second. I'm just going to track backwards. Lock. Now, do we have 8? We don't have it at the very end. So let's just add a few more, and then we're going to be done. I'm talking like we've been doing this forever. We've only been doing it for like, 11 minutes. But automated approach is much faster. I like this one since it's going to survive for a while. Okay, I believe we might have 8 trackers at any given time. We can, of course, check by seeing if we can get a camera solve. So, once you have these trackers and the data looks good, none of these seem like bad trackers. Oh, wait. 1, 2, 3, 4, 5. Hold up. Just a bit of a gap right here. We could fill that in easily. But what I was going to say is once we have 8 trackers at any given time, we can do our camera solve. So let me just add 1 here. And the interesting part of this is how do we use this ground information? I haven't made that clear yet, to extract the position of the beak. We'll talk about that. Okay, so let's see if this was enough. We're going to go to solve. We're not going to mess with any of these settings yet. Solve camera motion. At least 8 common trackers are needed for reconstruction. So there is some point in the shot, as you see there's this arrow down here, where we do not have 8 trackers. Where is that? Where does it feel like we don't have many trackers? We could add 1 at this point in the footage, and I think we need some more at the end. This is a good tracker. It lasts a long time. Okay, I'd believe it if roughly at this point in the footage we could use more. Lock, and let's see if we still have that error. Nope, we still have that error. Okay, we just got to really look for the areas where we don't have enough trackers. So this area is fine. Fine, fine, fine. Could this use an extra tracker? Don't know. May as well add it. In general, the rule of thumb is you want to have the least amount of solid tracks as possible to get a clean solve. Like, you don't want to add hundreds of tracks and all that, unless you want to do some fancy stuff with reconstructing the scene using a bunch of points. So we're just going for reliable trackers. If they're bad, we're not going to use that data. Okay. It must be around here that it happens, if I had to guess. Okay, I'd be surprised if we still have that 8 tracker problem. At least 8 trackers are needed for reconstruction. I'm losing my mind here. Boys, what's going on? Okay. Where do we not have 8 trackers? So like somewhere here? Like, it must be like we have 7 or something like that, because this seems very populated. Oh, yeah, here we have 8. Let's add a few more at the end since that seems like the most sparse thing. I'm sorry that tracking takes a long time, but that's just the reality. You can, of course, skip the tracking part if you desire. Okay. Still, you're driving me insane. Okay, this one starts to get glitchy. Track. Clean that up. There we go. Oh, you know what the issue might be, by the way? Our keyframe numbers, which are basically 2 frames that we pick that have a difference in parallax, maybe this range doesn't have 8 concurrent trackers. So maybe what we can do, let's see, is if we enable keyframe, yep, now we have a solve. Okay, there we go, boys. So it seems that we need it so that between this frame range, we have at least 8 identical trackers. Sorry about that, but nothing wrong with a lot of tracks. So you can see we have a solve error of 0.91 pixels. If you're not used to this, anything under a pixel is pretty good. But we can do a lot better. By now keeping this keyframe as is, so I'm disabling this so it's not going to search for new keyframes, so it's 74 to 86. You now enable focal length, so it's now going to guess, based off this information, how zoomed in are we? Go for another camera solve, and we're down to under half a pixel, which is very, very good. And you could clean this up, but I'm happy with that. So now we have our camera solve. Of course, it's not going to be in the 3D viewport. Our camera is stationary. To incorporate this, hit Setup Tracking Scene, and now you can see our camera is moving. Of course, it doesn't look very good, like it looks like the plane's floating above. Of course, this is because if we enable motion tracking, these empties, which represent the points, which represent the floor in some sense, are like hovering here, whereas our floor is supposed to be down here, so we need to solve that. Quick way to do this, select 3 trackers, hit floor, and this is going to make it so that, let's view this here, our trackers live on the ground, and we can see that especially if we make these a bit smaller. They're all roughly on the ground. We could do a bit more work to align this. And to make the camera further away, since it's like a microscope on this, it's like zooming in, we pick 2 trackers and say between these 2 trackers apply a distance of 1, which means that has to be bigger, or you can make it 5. The larger you make this, the further the camera is going to be. But now you can see that this is actually tracking on proper, right? It looks like the plane is moving. Okay, so I'm going to take this, delete it. Let's reorient our camera a little so that we don't have this sloppy X and Y axis. To do this, 3D cursor, and now we're moving the camera, which from the camera's perspective doesn't change our 3D track, right? So I'm just rotating it on the Z axis so that we have something like this and it's lined up. We can move this on the Y, the X. Again, we're moving our camera through space, but all these points remain on the ground, so it's still going to look correct. And that looks much cleaner, honestly. So now if I was to add an object, it tracks on perfectly. Okay, cool. So we're done with the first part of tracking. Now the interesting part, which is how do we get the position of the beak? Because, again, we have all this tracking information, but the beak is above the floor. We don't know where it is. So here's what I propose we're going to do. I'm going to basically outline the path that this pigeon takes, right? And we know that the feet are contacting the floor, so we can actually track the feet, right? But we know that the beak has to be above the feet. So in other words, if I know where the bottom of the pigeon is, I can extrapolate where the top of the pigeon is. So this is a bit of a confusing concept, but follow me here. What I'm going to do is I'm going to make a plane. I'm going to take it and scale it to 0 and do a merge by distance. Why? Because I want a single point, a single vertex. There's an add-on that does this, like extra objects, right? So single vert, but you might not have that. I'm going to take this vertex and position it right on the feet. So again, we know where the feet are. And if I go to edit mode, I can E to extrude, and I'm only moving this on the X and Y axis. I'm not going like this, where it might be going up on the Z. This has to be constrained to the ground. So here we have this. And I'm going to extrude, and you can see how I'm kind of like following the path of the pigeon. So here it kind of curves a little. So we move it on the Y-axis, and you can just go back and forth and just check that it almost looks like the pigeon's walking on this line that we're creating. And again, we're going to use this for a fancy projection idea. So something like this. Make sure that it's kind of weaving in between the feet. Doesn't need to be perfect, but it's going to give us less work down the road. Position this in between the feet. And here there should be like, it looks like it's like rounding the corner the pigeon is. So we should have a lot of curvature at this point. And by the way, you can also do this with a curve. I just prefer to do it with a mesh since we're going to do some edit mode stuff anyways. So here it's fully going on the x-axis, it looks like. So something like this and like that. So now let's visualize our path and see if our pigeon seems to walk on it. Doesn't need to be perfect. Looks like we could do a bit of work at the end here. Although that's actually pretty good. Okay, so we have our pigeon walking on the thing. I'm going to smooth the path by Control B to bevel, V for vertex, and C to clamp. So now we're smoothing the path. I just added extra vertices. And now the key insight is you can take this and extrude it upwards on the Z-axis, okay? So again, the idea here is we know that this wall that we created not only kind of shows the path of the pigeon, but it kind of cuts it in half, right? So this should cut the pigeon in half since we know the feet are here and we know that it's above. What this means is that we can track the beak in 2 dimensions and project it on this wall. And that's going to be where the beak is in 3D space, not just 2D. Okay, so bit of a complicated concept, but hopefully you're following. What I'm going to do is I'm going to save at this point. So I'm going to call this tutorial. Again, final project file I'll make available and all this. But now we can actually track the beak. So what I want to do is go back to the movie clip editor, go to clip, and we can do another track that's not for the 3D solve, but just for the beak. So again, all this previous frame, yada, yada. I'm just going to put a tracker here, and we can see what that looks like. And I'm going to track forwards. And the nice thing about this is it kind of automates a lot of this. We don't need to place the beak, the tracker on the beak that often. Like normally, it will track pretty well. Sometimes we have to do some manual correction. So I'm just going frame by frame, kind of adjusting it, G to move the tracker and all this. And it should be a super chaotic path since the pigeon's head's going back and forth and back and forth. We could increase our search area, that might help. So again, we're kind of extrapolating this 3D information to give us like something extra. And you could use this in a lot of, the theory of this you can use in a lot of contexts. Again, here it should get a bit confusing since the pigeon's going to turn to face us. Make sure it's at the tip of the beak. It seems like the track is worse whenever there's a lot of motion blur, which makes sense. So you have to kind of approximate it. Okay, so here it's getting a little weird. I don't even know where the beak is, so I'm just going to kind of eyeball it. As long as it looks right, it will look right when we put the joint on. Okay, so that should be our track. We could give it a fancy name or a color and all this. I believe, can you just like assign a color here for the tracker? Either way, this is our tracker, is the point. And you can see it's doing this whole thing. We don't want it to be, by the way, this looks funny as fuck. We don't want it to be part of our 3D solve, but we want to project it on this wall that we made. So in reconstruction, click link empty to track. What this does is you can see, or maybe my face is over it, but it adds an empty object. So you can see now we have this tracker that's projecting from the camera. Again, this is what I mean. We have this XY position, but we don't know where it is in 3D space. But when we have this tracker added, it creates a constraint where we can use a depth object being our plane. So you can see, whoops, you can see it's taking this empty, which looks correct from the camera view, and we're projecting it onto the wall. So now we know where the beak is in 3D space. And we can constrain this to F-curve, so it's no longer a constraint, but a bunch of keyframes. And in fact, we are not done yet. We have all the location data, but we still need to know the rotation of the beak, which we can eyeball somewhat. I'll show you how to do that. So in these keyframes, I'm going to go to the information. I'm going to delete everything to do with rotation. We just need its location in space, and we can set our rotation to 0. So now, let's get rid of some of this stuff so it's less confusing. Now we have an empty oriented upwards. That is the position. And you can see how the empty is kind of going back and forth like the pigeon head. For the rotation, here's a trick we can do. So the rotation matters because we need to know which way the blunt is facing, right? What I'm going to do is I'm going to scale this up just so we have longer lines with our empty. And I'm going to orient it. And this could be slightly off. We just need it to be consistent. I'm going to orient the empty so that this line cuts through the tail feathers exactly halfway. So you can see I've taken this and bisected it. Okay? You're like, okay, what's the point of that? So I'm going to add a keyframe for rotation. The point of this is we can go 20 frames down and now kind of rotate it on the z-axis, add a keyframe, go more frames down, add a keyframe, and this should give us some consistency. Again, this is kind of a rough eyeball approach, but it will get us 80% of the way there. And then once we add the blunt object, we can kind of do some finessing. But you can see the most rotation happens in the end here, which makes sense. So I did a quick pass where every 20 frames I did the thing, and you can see roughly it's moving and rotating correctly. Now what you want to do is fine tune. So we went every 20 frames, now I'm going to go every 10 frames. So I'm going to bisect the frames and kind of add detail. So this is a technique done in animation where instead of going frame by frame by frame, you kind of fill in the gaps, which should create less work in theory, depending on how chaotic the motion is. Okay, now we go back and we go to every 5 frames. And then beyond that, we just want to correct if there's any frame that's super off, if there's a sudden jerk or motion or something like that. So I'm just going through. You could add another tracker on the tail and do some fancy stuff with the drivers to do this automated, but I don't think it's worth it. I think the eyeball approach works just fine. And that's what I used for my shot. So something like this. And you have to imagine how it's oriented and what angle you have to do to bisect the feathers, since it gets a bit confusing. Something like that. Here we've gone too far. Okay, let's see what that looks like. So you can see it's not perfect since there's a lot of wobble on the walk, but it's mostly there, right? If you wanted to get granular, you could kind of go every couple frames where it looks off and adjust it. So just do a bit of a scan. So here it's off, adjust it. And this is really what's going to sell the effect. As long as the joint is oriented correctly in all this, that's what's going to make it look like it's actually attached and we did a good job with tracking. So again, I'm just going to the highest error areas where the distance is kind of off and just fixing it. So this is off for sure. And by the way, this tracking part of the series is probably going to be the most complicated, the theoretical part of it. So it's kind of smooth sailing from here once you've done this. Okay, we're getting close to the end here. Not of our lives, but of this tutorial. Okay, that should be a lot better. So now let's see if we, yeah, that looks much more correct. So you can see how this empty is rotating through space. And now let's do a bit of a test. We did all this tracking work. Does it work? Right? Let's add, I guess probably the best thing to do is use a cylinder, since that's kind of joint shaped. So I'm going to take our cylinder, kind of make it this thin thing. I'm going to, in 3D space, put it so it's resting on this empty, and I'm moving the origin so it's at the bottom of it. So I'm just aligning it with our empty, like that, and then you want to parent it to the empty. So right now it's just going to look like a cylinder that is attached to the beak. But because we also have the rotation, we can also rotate this forward and kind of eyeball whatever looks correct. It's a little hard to tell, right? But do something like this. And if we hide the wall and do this as a solid, you can see it looks like this thing's oriented correctly in 3D space and all this. And of course, we can do a second round of corrections to make this look better. But you can see this is kind of the essence of it. It kind of looks like it's carrying a cigarette, especially at this point. The cylinder rotates in the correct way. Right? So the rest of this is really creating the joint, adding a smoke simulation. By the way, the fact that this is moving through space means that we can do a smoke simulation where the smoke has the speed of the object and all this. But that is the essence of it. So thank you for watching part 1. Join me in part 2, where we are going to replace this cylinder with kind of a low-res model of a joint. I'll show you how to make that. And we're going to put it on there with the shading, texturing, all this. Okay.